Hey guys, Lewis here. Hopefully you can hear my voice. I'll try to adjust the audio in the post edit, but this is about as loud as I can get. So I'm going to try to talk to you about a few things. This was the video that we lost last Thursday, but I'm re-recording it now just so you can have it. Just kind of reiterating some things. All triangles have three sides. There were three sides that three different types of triangles that we talked about. Equilateral, where all sides are equal and all angles are 60 degrees. Isosceles triangle, where two sides are equal and two angles are equal. And then the scaling triangle, where no sides are equal and no angles are equal. Now, we also talked about this is the primary equation we use. We always use this, area equals 1/2 b times h, base times height. This is what we generally use. And here's just kind of some examples that I went through. I did some in class with you, but I just kind of went through this one. We have an equilateral triangle with a height of about 5.2. Since we know the height and we know the base, we can use area equals 1/2 base times height by saying 1/2 times 6 times 5.2. Throw that all in the calculator, and we rounded to the nearest tenth in this particular problem, and we get 15.6 centimeters square. This problem, I have a isosceles triangle, but I know the height, so I can use area equals 1/2 base times height. So area is equal 1/2 times 6 times 8, and I get 24. And then lastly, here's my scaling, where I know the base, I know the height, I use my same equation again, and I get 25. Remember, just like I told you in class, we can only use this type of equation when we know the triangle's height. Alright, so just to kind of touch on more some things, like I told you last Thursday, sometimes we don't know the height of a triangle, so we have to use, look at the triangle. This one has a 10 by 10 by 10, so we know it's an equilateral. So we have to use this equation. A is a squared times the square root of 3, all divided by 4. And we plug in our numbers. Area is equal to 10 squared, because that's the only number we can use is that 10, times the square root of 3 divided by 4. 10 squared is 100. Work this all the way out, and we get approximately around 43 feet square. And the isosceles triangle, we know it to be isosceles because these two sides are the same and this side is different. And remember, I told you to make sure, move some stuff here so we can see this a little bit better, to make sure that you don't just assume that the bottom piece of the triangle is the base. In this equation, the base is the oddball. It's the guy who is not the same length as the other two. So that's how we know which one is the base. And the other two happen to be A. Little a, not big A. So area is equal to 1/2 the base times the square root of a squared minus the base divided by 2, and all of that is being squared. Well, when we plug in our values, remember, try to work don't throw all this into the calculator first. Work piece by piece. So you know that 1/2 times 3 is 1.5. You know that 6 squared is 36, and you know that 3 divided by 2 is 1.5. So we've worked it out a little farther. Now take it just a little bit and work out the 1.5 square. Well, 1.5 square gives me this 2.25. Now let's work it out a little farther. 36 minus 2.25, and I get 33.75. This is about as far as you can take it on paper, unless you end up with a perfect square that you can use. But anyway, we have area is equal to 1.5 times the square root of 33.75. Work this out by using your calculator, and you ended up getting about 8.71 meters square. Right. The other we used in the class last Thursday was scaling, where area is equal to the square root of s times s minus a times s minus b times s minus c, where s equals a plus b plus c. This is what we called the hero's formula, and I told you it was great for two reasons. One, it will work on all triangles, and two, we're not going to be tested on it. So that's wonderful. Alright, so the other thing that we talked about last Thursday, just to kind of review with this video, was about the right triangle. A right triangle has a 90-degree angle, and this allows us to basically, with a simple knowing this, it's a right triangle. We know that this gives us our height, because recall that this little symbol with a 90 degree is usually our height. So with a right triangle, we just basically use this area equals 1/2 base times height. Our base in this case is going to be 4 and our height to be 3. Plug in those numbers. 1/2 times 4 times 3 gives us 6 meters square. Alright, and it's the same thing with this one. I'm not going to work it all out. You get the idea. You can copy this down in your own time. Alright, the biggest thing about the right triangle, not only it's easy for us to find area, but it has a unique thing called Pythagorean Theorem. And I told you last Thursday that this Pythagorean Theorem is like the foundation of modern trigonometry, and we won't go into that in this class, but if you happen to go to 121 and higher classes after that, this guy is going to haunt you for the rest of your life. But anyway, moving on. Remember, A and B, these two right here, A and B, are connected by the 90. They are your legs, okay? And C is the hypotenuse. Notice how that C is directly opposite the 90. So here's my 90, and the 90 points at my C, where my A and B are connected to it. All right, and doing some math magic, and because the various math gods say so, we get this equation: a squared plus b squared equals c squared. This basically means that we can find, if I give you a triangle and I only give you two sides, alright, such as this one, I only gave you two sides, 8 and 15, you can find x by using Pythagorean Theorem. So a squared plus b squared equals c squared. Plug in my 8, plug in my 15, and my x is going to go into place of c, because x is my hypotenuse. I have 8 squared plus 15 squared equals x squared. 8 squared is 64. 15 squared is 225. I add those together and I get 289. Now, I get what really I wish I had did this out. It was actually ends up, if let me rewrite this, as it really says 289 equals x squared. All right, this is what our next step would be. But remember what I told you, we need to get rid of this x squared, so we have to square root it. That's what this step is. I'm square rooting the 289 and I'm square rooting the x squared. When I do, the square root and the x squared cancel out, and that leaves me just x, and the square root of 289 is 17, and the answer to this is 17 meters. Now this one, I've given you the hypotenuse and one leg, but the procedure doesn't change much. I still use a squared plus b squared equals c squared. I plug in x in the place of a, 24 in the place of b, and 25 in the place of c. I solve. 24 squared is 576. 25 squared is 625. I subtract in the 576 on both sides, and that gives me, and I'll rewrite it just like I did a while ago, x squared equals 49. Now, I have to get rid of this x squared, so what did I do? I square rooted it, and since I square rooted this, I have to square root 49. And when I do, I get x is equal to 7 inches. Alright, here were some other ones that we discussed in class, and I'll just kind of briefly mention these again. You have a triangle that has a triangle hole that's been cut out of it. So in order to solve this, we needed to take the area of the big triangle, which is out here, and we were going to subtract the area of the small triangle right here. And we know that this triangle is an equilateral. And we know that this equilateral has is 3.6 centimeters on the outside. And we know the small triangle is also an equilateral, which is 1.3 centimeters on that side. Well, knowing this, we can plug in an equation, and you'll have to forgive me, my voice is about to go, so I'm not going to walk through this entire equation. But you solve using the equilateral equation, and you round your answer. It says round to 3 significant digits if necessary. I forgot to tell you that. I'm going to round this to 3 significant digits necessary. I solved this out and I rounded it to 5.61 centimeters square. I solved all this one out and I got 0.732 centimeters square. Well, now that I know these two answers, I can subtract. And I'll move this up. 5.61 minus 0.732. When I do, I get this, and then I round again, 4.88 centimeters square. All right. Here's another one we talked about in class. It has two shapes. The purple was a rectangle. The red was a trapezoid. We find the area of the before we start trying. Let me rephrase. When we know both of these shapes, we're going to add them. All right, so let's look at some measurements first. We know from here to here is 12, and we know from here to here is 9, but this side is missing. So how did I get 3.5? Well, I took the 12.5 minus 9, and I got that this length right here is 3.5. Now that I know this length, I know all the measurements I need to calculate not only my rectangle, but my trapezoid. All right, so my rectangle is going to end up being 6 by 9, which I have right here, and I multiply to get 36. My trapezoid, remember, my bases of my trapezoid are always parallel, so this side and this side are parallel. So my 10 is a base, and this 6 right here matches this side, so this is a 6. So these two are my bases, 10 and 6. My height is the distance between the bases, the vertical distance right here. So now I know that, I can say 10 plus 6 divided by 2, 10 plus 6 divided by 2, then multiply by 3.5, work that out, and I get 28. Since I know this is 36 and this is 28, I get an answer of 64 inches square because I had to add them. Alright, lastly, I had this weird shape. I can't remember if I talked about one like this in class or not. But this shape can be broken up into two shapes. I can have a long, skinny shape here, rectangle, and a kind of like a stubby box here. So now I know what the area, I'm going to say that this is the area of the purple and this is the area of the red. When I know that, my area of my purple is going to be 6 times 36, and I know that's going to give me 216. My area of the red's a little bit of a harder problem because right now I only in your picture you only know this distance right here is 15. But what about from here to here? Well, recall something that we did in an early video, how to find these measurements right here. I think we did an early video. Anyway, if we didn't, you know that the entire shape is 20 and this side is just 6. But if this is all 20 and this is 6, that should be able to figure out what this missing side is by saying 20 minus 6 gives us 14. So we know that this shaded red is going to be a 15 by 14. When we plug that into our calculator, we get 210. So I know the area here, add it together, and I get 426 feet square. Now, again, I apologize for my voice. I can't help it. I am very sick. But I wanted to record this video while my voice was somewhat good. Again, like I told you Thursday, you are required this material, although I'm not going to require you to have it on Tuesday, but I did want you to have it for now, just so you can see. Alright, I'm going to record one more video, and then I'm going to go to bed. Alright, see you in the next video.